Hi there everyone, and welcome to Mostly Math. Today we'll be evaluating some elementary telescoping series from high school math. Okay, we'll start off with this one that everyone knows. Sum then goes from 1 to infinity of 1 over n times n plus 1. This is a proof that you've probably seen before. I'm doing this because I'm going to make a generalization to a series that you might not have seen before. So first let's evaluate this so we can see the pattern. So I get this as a review. So we evaluate this using partial fraction decomposition. It stands for a partial fraction decomposition, which I will refer to as PFD, which is a standard acronym for this sort of thing. What you want to do is break 1 over n plus 1 into something over n plus something else over n plus 1. And we can do this by making a guess. If you've seen this kind of technique before, you would make this guess and you'd be right. 1 over n minus 1 over n plus 1, which if we combine the common denominator as n plus 1 minus n over n plus 1. N's cancel is just 1 over n plus 1. So this is a good guess. And this is how we can decompose this into the product of the functions in the denominator. So this is simply sum then goes from 1 to infinity of 1 over n minus 1 over n plus 1. Now we just start evaluating terms basically and see what we get. So for the nth term, we start off with 1, of course, to get 1 minus 1/2. And for the second term, we get 1/2 minus 1/3. For the third term, we get 1/3 minus 1/4. And for the fourth term, we get 1/4 minus 1/5. This continues on indefinitely. We see that these actually cancel in a pairwise fashion. So this term in the n equals 1 term is just going to cancel pairwise with the first term in the n equals 2. And likewise for 1 over 3 terms, etc. We see everything cancels except 1. So the value of this sum is indeed 1. You have most likely seen this before. If you've seen any telescoping series, you've seen this one. It's the most famous and the most useful. And now we're going to do a slight generalization. We are going to replace 1 in the upmost expression by 2. See how we can evaluate that. Okay, if I just replace it with 2, well, 2. We need the partial fraction decomposition for this. Thankfully, it's not too difficult though. Let's make the same guess that we did before. Let's take a look at 1 over n minus 1 over n plus 2. If we do this, then it's going to be n plus 2 minus n over n plus 2. N's cancel again, but now we have a factor of 2 on top. But that's pretty easy to get rid of. Just multiply our guess by 1 over the factor of 2 to get the answer that we seek. This is actually 1/2 times this, but 1/2 everywhere. 1/2 times this, which is equal 1 over n plus 2. So we see that we can do the same thing before, we just have an extra half. So let's do that. It's going to be 1/2. The sum is n goes from 1 to infinity of 1 over n minus 1 over n plus 2. Let's go ahead and evaluate it just like we did before. So it's going to be 1/2. I don't have enough room anymore, do I? And for the first term, we're going to have 1 minus 1 plus 2, which is 3, plus the second term, we're going to get 1/2 minus 1 over 2 plus 2, which is 4. Sorry, 4 goes on the bottom. Plus the third term, going to have 1/3 minus 1 over 3 plus 2, which is 5, plus the fourth term. Going to have 1 over 4 minus 1 over 4 plus 2, which is 6. And this continues on indefinitely. And we see that we're still going to have some cancellations, but it's not going to be pairwise like before. We see that one's not going to cancel. This 1/3 is going to cancel with that one. 1/2 is not going to cancel. 1/4 is going to cancel, and all the rest of the terms will cancel as well, leaving us with 1/2, 1 plus 1/2, which is just 3/4, of course, since 1 plus 1/2 is just 3/2. And we can also write this as another way. This is actually equal to the second harmonic number divided by 2, where the kth harmonic number is defined as a sum of 1 over n, as k equals 1 to n. So this is a hint at the pattern that we're going to see later. And in fact, I am not going to prove this one, but I am going to state it. If we evaluated the sum as n goes from 1 to infinity of 1 over n, n plus 3, if you want, you can certainly perform this elementary exercise for yourself, just for clarity. If you wanted to do this for yourself, you would see that it would actually be 1/3, 1 plus 1/2 plus 1/3. So we have 1 over a number times the same number in the harmonic series. So, of course, the next one will be 1/4, 1 plus 1/2 plus 1/3 plus 1/4. And if this argument isn't clear, I do urge you to evaluate the k equals 3 case here to demonstrate to yourself that it is true, because we're going to do the general case now. We are going to replace 2 with an arbitrary number k up there. Has to be an integer for this to work, of course. It's possible that it could be generalized to accept non-integers, but we're not going to be discussing that in this video. You can feel free to look up the Wikipedia page for telescoping series if you're interested in that sort of thing. Okay. Okay, so now we're going to replace 2 with k up here. And let's do a partial fraction decomposition again. Well, we're going to guess 1 over n minus 1 over n plus k. And I'm just going to save you. I'll just do it. It's easy. So we have n plus k minus n over n plus k. These bad boys cancel. So it's just k over n plus k. And we see if we wanted to get all this k out of there, just feel free to divide by k. No problem. Just go ahead and do it. Because we can. We're so cool like that. So we can partial fraction decompose an arbitrary integer here by just multiplying 1 over the integer and then subtracting them. Let's begin. So we get a 1 over k out front. We have a sum as n goes from 1 to infinity. We have 1 over n minus 1 over n plus k. Now let's go ahead and evaluate it down here. I am going to just evaluate the sum. I'll just keep the 1 over k here. So this is going to be equal to, for value of n here, I'm going to have 1 over k. And now we just evaluate the sum of the interior. We're going to start with the first term here. 1 minus 1 over k plus 1. And the second term, we're going to have 1/2 minus 1 over k plus 2. Plus the third term, we have 1/3 minus 1 over k plus 3. And you can pretty much see the pattern here for the fourth one. Fourth term, 1/4 minus 1 over k plus 4. And this continues until we get to the n equals k term. So for that term, we're going to have 1 over k minus 1 over k plus k, which is 2k. And then for the k plus 1 term, we're going to have 1 over k plus 1 minus 2k plus 1, 1 over 2k plus 1. And next term, k equals 2, we're going to have 1 over it, of course, minus 1 over 2k plus 2. Pattern is pretty clear at this point. K equals 3, 1 over k plus 3, minus 1 over 2k plus 3, continues indefinitely. And at this stage, let's see what cancels. So we have the 1 is still going to be there. K minus 1 is going to cancel. We're going to have k plus 2 is going to cancel. And let's see, k plus 3 canceling. Yes, k plus 3 is canceling. And we have k plus 4 canceling with something that we haven't calculated yet. It's actually the next term. And we see we have a bunch of new terms. And the next step will be to evaluate all the 2k terms. If you did that, you would see that this term would cancel with something here, this term cancel with something here, this. So everything would keep on canceling except all these constants here, 1 over integers, added up all the way to 1 over k. And I'm going to say that this is equal to 1 over k, 1 plus 1/2 plus 1/3 plus etc. all the way to 1 over k, which we can rewrite as 1 over k sum n is going from 1 to k of 1 over n, which can also be written as the kth harmonic number divided by k. So now we have a generalized formula for this bad boy. The general telescoping series 1 over n times n plus k can simply be written as the kth harmonic number divided by k. I think that's pretty cool. And these do come in handy in many places, since a priori a series like this would look like it's difficult to solve until you try to telescope it, which honestly should be the first thing that you try on a series like this if you wanted to evaluate it. And I hope you learned something. Hope you can fill in the rest of the terms here for an exercise. And if you enjoyed this, want to see more, feel free to subscribe, tell your friends. See you next time.